Let's kind of go through some of this because, as we've seen on many of our last tests, our future tests all have review kind of questions in them, so it'd be good to just review this stuff and make sure that we're going in the right direction and that we're remembering things. So we have 2x squared minus 4x, and we're going to subtract 30 to the other side so that we can get everything set to 0. All right, now one thing you should notice in this case is you have 2, 4, and 30. They're all divisible by 2, so we're going to take a 2 out. So you have minus 2x minus 15 is greater than 0. Okay. Now, we can factor what's inside the parentheses. So we're going to leave the 2. We're going to have an x greater than 0. So we need two numbers that multiply to be negative 15 and add up to be negative 2. All right, it's going to be negative 5 and positive 3. Now we solve these both. So x minus 5 is going to be greater than 0, and x plus 3 is going to be greater than 0. So x is going to be greater than 5, and x is going to be greater than negative 3. Okay, so now what we're going to do with this is, because we want to solve the inequality and we want to write the answer in notable notation, my best suggestion is to graph this. Okay, so it's going to make a quick coordinate plane. All right, so some quick notes on graphing. We have the x-intercepts. They're going to be at 5 and negative 3. All right, and since we know that this equation has a positive in front of the x squared term, it's positive 2, that means the graph's going to go up. So we want to know, where is this graph greater than 0? Okay, if the graph is greater than 0 here and here. Okay, we're talking about greater than 0 on the y-axis. Okay, so if we're writing this interval notation, if we're going left to right, all right, it's greater than 0 from negative infinity to negative 3. All right, then it takes a stop at negative 3. I'm going to change the color here to help us illustrate this. At negative 3 all the way till it gets to positive 5, it's below 0, so that's not good. So let's go back to blue. So we're going to start up again at positive 5 and then go towards positive infinity. That's where we're going to end. So there's the graph and the interval notation that goes along with it. Okay, so this would be your answer. Okay, we've got 2 more to go. It's a short day. All right, so next we're solving this. Now, some people's first inclination is to multiply everything together, but it's already been factored once. What we have, though, is this first factor is itself factorable. It is specifically called the difference of 2 squares. You have 2 perfect squares here, so we're going to factor this again. So you have x and x, all right, and then you have 2 numbers that multiply to be negative 100 and add up to be 0. So it's going to be positive 10 and negative 10. And we still have the 3x plus 5 left over. Okay, so we have x is equal to, if we solve all these for x, we're going to get x is equal to negative 10 to positive 10 to negative 5 over 3. And that's it. All right, last one. Okay, so this is a radical equation from the previous unit. Okay, and what we want to do is we want to get the square root part. I'm going to highlight that part. We want to get this part by itself. Okay, in order to do that, we're going to take this x that's outside, the minus x, we're going to add it to the other side. So we have the square root of 7x minus 5 equals x plus 1. Okay, now we did that to get the square root sign by itself, because now that it's by itself, we can square both sides. Okay, the square root and the square root will cancel each other out. We get 7x minus 5. Okay, and then the other side, because you're having a quantity squared, the x plus 1 is the quantity, you're going to multiply that by itself. Okay, so you have x squared plus 2x plus 1. If you multiply everything out and distribute using the distributive property, that's what you'll get. Okay, now we want to get everything on one side of the equation to set it equal to 0. I'm going to suggest you subtract the 7x and add the 5. Okay, the reason I would do this is because if you do it the other way, you'll get a negative x squared, which makes the factoring process a lot more difficult than it has to be. So I end up with x squared minus 5x plus 6 equals 0. Okay, if we factor this, we'll get x and x. You will have two numbers that multiply to give you positive 6 and add up to give you negative 5. That's going to be negative 3 and negative 2. So you're going to solve both of these. For x, you're going to get 3 and 2. Now, again, we did this the prior unit, and one of the things you have to do is check these to make sure they work. Okay, so we're going to use a space down here to check them. So you have the square root of 7 times 3 minus 5 minus 3, and then is to equal 1. So that's the first one. And then the other one, square root of 7 times 2 minus 5 minus 2 equals 1. We've got to make sure these both work out. So 7 times 3 is 21, minus 5 is 16. The square root of 16 is 4. And 4 minus 3 equals 1. And that checks out. Okay, the next one, 7 times 2 is 14. Minus 5 is 9. The square root of 9 is 3. Minus 2 equals 1. And that also checks out. So these both work. Okay, and that is it for today. Tomorrow we're going to start something new. We only have about 2 more sections to get over before we're done with this unit. And then hopefully we'll be back in school. All right, so hopefully everything's been going well, and I will see you soon.